Hi, I'm glad you're tuned in here to watch this screencast on finding the slope of a line when given the equation. We have talked in recent lessons about the standard form of a linear equation being ax plus by equals c. And one of the things that I always tell my students is that if you've got an equation of a linear function in standard form, you can certainly find the slope. The letter that we use just for a shorthand way of referring to the slope, by the way, is m. And in our last screencast, we talked about how m is a comparison of our rise over our run, or the change in y over change in x, or y2 minus y1 over x2 minus x1. Well, when you're dealing with an equation in standard form, you can find that slope to be the opposite of a over b. This would be something interesting to commit to memory for those of you guys that have a good memory. If you have an equation where you know it's if you have a line where you know its equation in standard form, so for example 2x plus 3y equals 6, you could very easily determine the slope of that line having been given in its equation in standard form. So I would say that m equals, all right, now identifying my a value means what is the coefficient in front of x? So in this case, a is 2. Identifying b tells me to look for the coefficient in front of y, so b is 3. And then for my formula, I say the opposite of whatever a is. So if a is positive, the opposite of that would be negative. And divide by b means divide by 3. And there we go. That is our slope. So whenever you're given the equation of a line in standard form, super simple to find the slope. Just do the opposite of a over b. Okay? I'll give you one to try. Here's your example. Negative 5x plus 4y equals negative 20. All right? Pause your video now and see if you can find the slope of that line. All right, if you've done your work correctly, you should have gotten m equals the opposite of negative 5, that's our a value, divided by 4, that's our b value. Now the opposite of negative 5 would be positive 5, so your slope is 5/4. And that's the way that we find slope, rise over run, for that particular line. Now, sadly, we're not always going to be given the equation in standard form. For example, we might be given something like 20 plus 4y equals 5x. Okay? So what you can do is you can very quickly put that in standard form. In this case, I might choose to subtract 4y, for example, from both sides. Whatever I do on the left, I do on the right. And so now I've got myself an equation, 5x minus 4y equals 20, and it's now in standard form, and I could find the slope. You might notice the slope in this one is the same as in the last one. So the slope would be the opposite of a. Now my a value is 5. So the opposite of 5 over b. And in this case, my b value is negative 4. Negative 5 over negative 4 winds up being 5/4, which tallies with our previous example. That's the same line. I just reworked it, put it in a different format. Now, that's all good and well, but as I mentioned a moment ago, we're not always given a line in standard form, and sometimes it's not to our advantage to put a line in standard form. I might have a line in the form y equals mx plus b. Now, this is not known as standard form, but this is a very, very important form. I'll put a couple stars around it here. This is what's known as Slope-Intercept Form. Slope-Intercept Form. And Slope-Intercept Form is perhaps a little bit more useful to us than standard form even is. Remember we said with standard form, this was a couple of screencasts ago, we said that you could easily determine what the y-intercept is and the x-intercept by plugging in and doing a little bit of work to find those values. Well, in this case, with slope-intercept form, you're actually going to be given the slope, and you're going to be given one of the intercepts right there in the formula. And in fact, our slope, again, is the m value, and our y-intercept is going to be the b value. So in your notes, I would write down that my slope is still going to be m. It's whatever's going to be in front of x in this form. But then the b value here, this is my y-intercept, or my yint. I'll sometimes refer to it as. Remember, that's where the line crosses the y-axis. All right, that's a special point that we call the y-intercept. So sometimes you're not given the equation of the line in standard form. Sometimes you're given it in slope-intercept form. For example, y equals 1/2 x plus 3. Y equals 1/2 x plus 3. And if I were to ask you, hey, what's the slope of that equation? There's nothing easier. It's just the number in front of x. You would say, my slope is 1/2, and away you go. And in fact, you guys have had a homework assignment practicing graphing lines in standard form. And one of the methods for graphing lines is to actually put it in slope-intercept form so that you can note what the slope is, in this case being 1/2. You can note what the y-intercept is, in this case being 3. And then, as I mentioned a moment ago, you could slap that down on a Cartesian plane just as fast and as easy as you like. There's the x-axis, there's the y-axis, the y-intercept being 3, there it is. And then the slope, remember, being rise over run means I would go up 1 and over 2. I'd go up 1 more and over 2 more because I like to get 3 points on my line. And there is the line whose equation is y equals 1/2 x plus 3. So not only did we find the slope of that line in slope-intercept form, we were also able to graph it out. So slope-intercept form is a super powerful, super helpful form for us now to put in our bag of tricks along with standard form. You'll recall, again, that standard form is ax plus by equals c. Now slope-intercept form is y equals mx plus b. Now, I do want to make a note that these two b values are not the same thing. We have a limited number of letters in our alphabet, and I suppose that when they were developing the notion of algebra, they just said, well, we'll just use b in both of these cases. It's unfortunate, but that is the way that it is. So those two values are not the same. They're used in different contexts. So just bear that in mind. Now, there is one last little example I'd like for us to work in this, and that is moving from standard form into slope-intercept form. Okay, now we did discuss this. I believe I've got this pulled up in a previous homework assignment that you guys were working for your algebra classes. But when we talked about this process by which you get y alone, or you solve for y in terms of x, I gave you guys 2 steps to follow. I've got them highlighted right here on the screen, and in fact I'll go ahead and copy them into our current notes page. The first one is to move the x term over, all right, and then solve for y by dividing away its coefficient. Now, I want you to practice that with me here. I'm going to give you an equation in standard form. I'm going to give you the equation 2x plus 3y equals 6. And we're going to go through, we're going to get the x term on the other side, and then we're going to divide by the y coefficient. So first things first, to move that x term over, we're going to change sides, use your inverse operation of subtraction. So whatever I do on the left, I also want to do on the right. And as I mentioned in class, it's always a good habit to list that x term first, because that's how it is in slope-intercept form. So I'm going to say 3y equals, instead of 6 minus 2x, we'll say negative 2x plus 6, using that commutative property of addition. And then lastly, so that's the first step, move the x term over. Lastly, we're going to divide by the y coefficient. Here we will divide by 3. Divide by 3, whatever I do on the left, I got to do to the whole right-hand side. So dividing by 3 to get y by itself, I now have y equals negative 2/3 x plus 2. You may ask, where did the 2 come from? That's just a simplifying of the 6 over 3 there. And then don't forget that we can pull that x factor out of the numerator and just write it out to the side as I've done here so that I can really easily identify what the slope is. The slope in this case is -2/3. That's my slope. And the y-intercept, that yint that we were referring to a minute ago, would be +2. So the whole point to getting y by itself in this example, although I'm not, opposed to looking at an equation in standard form, I get a lot more helpful information from slope-intercept, so that if I wanted to, let's say, graph this out, I could easily do that. It's got a y-intercept of 2, so I could put that right there on my y-axis. And then it's got a slope of -2/3, so I go down 2 and to the right 3, or I go up 2 if I wanted to go in the reverse direction, and to the left 3, because that negative could be applied down here at the bottom just as easily if we wanted to say +2 over -3. And then last but not least, we connect the dots, and there's the graph of that line. So I hope this screencast has been helpful to you guys. If you have any questions, please do let me know, and we'll continue on in section 8.3 tomorrow.